My friend was asking me that how to repair a Sony, and I tried to make search for him. This is a search I discovered after the time he asked me that question. That because you see here, this is Sony. This controller chip. It's out. Now we're not using the power supply as you see here. We're not using it, but we're going to use the secondary part on this power supply. We just use the secondary part and our universal power supply, like this. You can use any universal power supply because this Sony panel, it uses 2 voltage. It uses, as you can see here, it uses this 3.3 detect power, 12 ground T on, dimmer BL on, BL error NC. But for that we can do the what we call a shortcut, or we can use the bypass for some of these Sony, because some Sony detecting each and every voltage that goes to the power supply. But what we're going to use per now, we're going to use our universal power supply. We use the same when we're connecting it on this Sony power supply. That is the only trick we can use. And we have to be with the assistance of this power module, which makes 3.3, 5 volts ground, and as you can see, this is the power module. DC to DC power module. First to receive DC input and to make DC output. We're going to use by assistance of this power module so that we start our TV. Because what we need on this power module, we need the standby voltage made by 3.3. This one, as you see here, 3.3, and then we bring it here. We use this yellow wire. We bring it here. This is a source of 3.3. Because you see diode, this is a small transformer, because it uses this transformer. Then we use the correction, the positive of the diode, where the supply of 3.3 created on this board. You see here 3.3 designed by, this is 12 plus, and this is the otoscope. And we can't use it, we're not going to use it. Because this is autocoupler, which detects to switch this power. Because when it detects this, after detecting here, when you're switching on this power supply, the autocoupler orders, and then it's switching both the power supply one, which is this one, the main it's switching this power supply, which making 24 volts and creating 12 volts. This is 12, as you can see here. This is 12 volts, and this is a winding for 24 volts. You can see it on the diagram. When you trigger here the power supply, it's switching on this one, because this is another power supply. This, because it consists of 2 power supply. This first power supply, for it's creating the standby power voltage of 3.3, and this one creating the voltage of 12 volts and 24 volts by the assistance of the 3 autocouplers. One is power detection, another one is power AC input, where it see the current movement, and another one is switching on the power supply of this secondary part of this part. But now it even uses, you see here we have it uses the support of 2 MOSFETs, which triggered by this IC, because some of this IC has no numbers. You can see it here. It has no number, no any number you can see from this IC. Like that, that's how we're going to, that's how we create it. But now we are on wiring and the diagram. You see this power supply? This power supply has, we have to switch it directly by not using the Sony motherboard. We have to use it, you see, ground 5 volts, power on, 5 standby, 5 ground, and 12. Sometimes you can connect it directly from this power source, but that is sometimes confusing, and some of power supply, some of motherboards detecting this voltage. When it's higher, you can find that it cancel and it can get board you can damage the board, the motherboard. What we do, we have to cut this voltage up to 3.3 because it was better to connect it on 5 volts, but what we need is 3.3, which we create by using this module. Panel, this is 24 volts. This is 24, as you can see here. These two wires, we connected them directly to 24. This is 24. This is 12 volts. We connect it to 12 on this Sony power supply. And we connect this module to 12 volts. Then after connecting it to 12 volts, to switch so that it can switch. After switching, we get 3.3 up here. This is the diode, but this is where this 3.6 created the input. By doing that wiring, everything done okay, and now we're going for a test. You still see that these cables are connected. We're connecting the cables, but we're using it because we don't want to cut these wires. For now, connect them on this another power supply. That's why we're using transferring some wires from this power supply to this power supply. Now we're already connected. Here we're going to connect our inverter. Now here we're going to connect, this is inverter. This inverter uses 24 volts. Now we're connecting it, connecting the cable here. You see here it's 24. Now we're connecting our inverter socket to test our power supply. That is why, to identify that we're using power supply, this power supply, that's why these wires are coming from here. And this power supply on the side, and this is a power cable. You see the power cable? Now we're going to plug the power cable into the power. This is our power. This is our power module on the side. We plugged it in the cable. Our Sony is now, you see the power supply. As you can see the power supply. Our TV is now on, you see. It's indicating HDMI input, and you see down power. It's showing green. It means that our TV is now working very well by using the on-side. This is on-side power supply. And by here you can. Now our power and external power are done okay and are successfully connected. Thank you for watching. Don't forget to subscribe my channel. Leave the comments. Well, the more you leave the comments, the more I will do. Ask me the questions you want so that we can do it together and we share the knowledge on this my YouTube channel. Thank you for support. Thank you for watching. Don't forget to subscribe my channel. You can visit on you can visit me on Facebook by logging in and search Kapodis Bukenya. You can get me, you can contact me on Facebook so that you can chat via Messenger. For now, we're going to cut our board because we have to remove this part. The reason is when we put these two power supply, will not go. All need to be extended. Now, what we do, we have to minimize the size of this power supply because it's too long, so that we minimize the power supply so that we can fix this one in the same. We can fix this power supply also. Now we have minimized our power supply from this big size to, because we want to use always secondary part. But now we have minimized it like this. We have removed the primary, now we remain with always secondary. As you see, but now we're going to retest again after minimizing our power supply. Because we have to do this to save the space, because sometimes you see the TV have very little space inside, even though we can use other places, but after connecting this part from its angle like this, after placing it like this, here we can get another space where we can use this one, or we can put it downwards. Can put this one downwards like this, so that we save the space. We do it saving the space of the TV inside, to see where we can replace them very rightly and correctly. See, but now we're going to fix everything in the right angle. We put our screw. Try to screw back each back the position. I have screwed our half power supply tightly. Now we're going to screw this one, our power, another side. We screw it. Like this. This is our power. And then now we're going to look for space for our power supply. Where we can fix it. It's going to be fixed, okay? This is our power cable. begin to do small test. Switch table on. You see? And see from the backlights here, when the TV is reversed, you can see that the lights is now switched on. And we come to the front part, our TV showing. HDMI and power is on. Well, someone can say that if I cut the power supply into the piece, it can fail to work. This is our Sony Bravia. You see, it's our Sony Bravia. Thank you for watching. Don't forget to subscribe my channel. Keep on visiting my channel. Leave the comments. I'll keep on dropping more videos. Thank you for watching.